the presentation will be given by Professor Sester. So you can just start sharing your screen now.
Okay, thank you very much. I'm going to share our first ideas about how to improve a takeover situation by actively communicating information of the environment. My background is geodesy and geoinformatics, so I'm a person who is interested in interpreting spatial data and deriving sense from it. And this is how these ideas came about. So it's mainly from a data processing point of view. So the idea of, or the problem is that you're sitting in an autonomous car, you're reading newspaper, and then the system tells you to take back control because there's a situation it cannot cope with. And obviously this takes time to take over. There are studies which say that 7 to 8 seconds are needed, first of all, to just get back from a complex office task to deactivate the automatic system. And also then the driver has to visually scan the environment and find out what is the situation about. And this also takes another 11 to 13 seconds to make these safety relevant glances and then be able to do an appropriate control. So, and the problem is, or the idea would be that if a system was provided with essential information about the environment, then it can adequately react quickly and the driver still feels safe and informed and in control of the situation. So then the idea is that a driver who has to take back the control has to be aware of the situation. So in order to get this overview, he or she typically looks around through the mirrors and so on to get this sense of the situation. And the idea would be to mimic this process of looking around and getting aware of a situation by providing the users with information about the scene around them. So it's knowledge about the objects, their potential behavior, but also the context these objects are in. And this triggers several research challenges. So first of all, what are the relevant objects that have to be communicated, they have to be identified and shown to the user? Which of these objects require an adaptation of a driving performance? So not all of them might be relevant. Then how can the attention be guided towards these relevant objects, and how can the system make sure that the users understand the meaning and what he or she is intended to do? And of course, the question about how this information can be adequately communicated. Is it just visual? In what way is it visually communicated? And also, is it communicated just in one instance, or could it be also segmented into a sequence of actions? So concerning the relevant objects, one idea is to use these 6 levels. The 6-layer model for structured description of urban traffic and the environment, where we have, of course, the network, the layout of the road, and the corresponding objects. Then we have environment in terms of roadside structures, temporary objects, dynamic objects, and of course also environmental conditions like day and night, weather conditions, and so on. So I think these might be very good or very well suited to take into account as elements that have to be communicated to the users. But in addition to that, we would say that also some of these objects, they might trigger a certain behavior. So for instance, if you see this bar, of a roadwork sign, then this it's not just this bar, it also triggers some behavior, because it might be that there might be a traffic jam before that, and it leads to certain detours that are triggered. And also here, this is just a building, but if this building is, for instance, a school, then you might expect at certain times that a bunch of kids is standing around there, which also trigger some behavior. And the idea is to also not only recognize and visualize these objects, but also their potential behavior they might induce. Okay, and how can this be done? And this is from an automation point of view, what can be automatically extracted. We saw this from previous presentation already, that using our environmental sensors, we can use deep learning and extract objects like other cars and also objects of the infrastructure. What you can also do, if we do not have one single instance of data capture, but repetitive data acquisition, is that we can find out more about the temporal behavior at certain locations. So where do pedestrians cluster, for instance, and this can be then visualized or coded in such heat maps. So this could be, for instance, the location of a school where at certain times you can see expected pupils standing there. And this is also, of course, a very important information that we as humans typically have, but for an automatic system, they might be very valuable. And in the scenario of a takeover situation, it might be very good to get such information as well. Okay, what also can be done is the temporal behavior of objects at certain locations can be identified. So this is work that they did where the static objects are shown in green and the dynamic objects are shown in color. And so we can see that the situation might look the same, but at certain times, for instance, seasons, we see more or less vegetation. And this also has an effect on our reactions. For instance, it might obstruct our view. Okay, and of course, also the projection of a behavior is very important, like how will a person walk or continue his or her way. That's also very, very important to know in order to react accordingly. Okay, beyond these identification of individual objects, I think it's very relevant to understand the scene context, like the complex relationship between objects. A car is approaching, a car wants to overtake, a cyclist is crossing the road from the left, and so on. So these are this information that is also very crucial. And there are some approaches in computer vision that do research in that direction. So for instance, here is an approach that uses image captioning in order to derive some kind of stories about such images. So here there are two cars, a motor, I think a motorcycle is ahead, some pedestrians are crossing the road and the traffic light is red. So this is a scene understanding that is also very valuable for the situation I've been describing. Okay, of course, then you need the design. It can be also in different modalities like visual, auditory, or combined. You can use the head-up display. The visualization can be overlaid on a real situation, but also strongly schematic. So this is what has been presented earlier. You can also use some schematic presentations, or also even further, more cartographic presentations where we show just the scenario. We can show the projection of the users. You can also identify critical situations where the driver has to especially look at or only selectively present them. So there are different options. And of course, then there's also the question whether not only these instances should be presented, but also sequences of actions that the system would recommend, namely looking at something first and then taking care of something other. And this reminds me of something what an attentive or trusted co-driver is doing. He says, hey, please look at this side because that seems to be very critical. Of course, all these issues have to be tested intensively with user tests. But then I think this could be something that we could work towards, because I also think, and I get more and more convinced also during this workshop, that the acceptance of such system will largely depend on the ability of people to interact with them and trusting them. So this smooth handover will also enforce this trust. And for that, I think that the scene understanding and situation awareness is very relevant. And if you can communicate that in an adequate way, then the overtaking will be more smooth and leading to a higher level of trust and also acceptance and ultimately at higher road safety. Thank you.
Thank you very much for the very nice presentation. So I would like to open the floor for questions. So I see a question from Cheng. Yeah, just go ahead.
Yeah, thanks very much, Monika, for this, Professor Sester, for this presentation. Yeah, so I'm from the other area, so my question might be a little bit stupid, but I really like your idea about the like the object is not only the object, but also represent the whole consequence of a lot of behaviors. So I was wondering, in your, let's say, possible design or some HMIs, would you consider to include the possible consequences, like, let's say, maybe a prediction or something like a like warning, or just, you know, some indication to let the user know there might be some more hazardous, more dangerous consequences related to the object? Or do you think maybe this kind of information was too much for them to see? Or do you think that's a possible way?
Yes, I think this this might be very good. And actually, since I'm not a psychologist, but in our group there is a psychologist, he might have an adequate answer to that. From my point of view, I think that would be very valuable, just to know what might be perhaps the most important thing to look at, because that might trigger the largest hazard, as you say. So that I think that would be very valuable to have this information as a driver.
Yeah, thank you. Then I really look forward to the more designs about this. Thank you.
Mm-hmm.
So is there any more questions? Yeah, please raise your hand, or you can just go ahead. So I actually have one question. So my question would be to like foresee or to measure the situation awareness of the drivers. So how can we combine this information and help to design a good HMI system to improve the safety for the driver as well as for the road user outside the autonomous cars?
Okay, you are not talking about this external HMI, but still inside the car, who has to take care of vulnerable road users? Is it what you are asking?
Yeah, so the first part would be how the driver would take over. How can we actually help using this information?
Yeah, I think the crucial thing will be the design of the user interface. And also, yeah, these are all first ideas that we have sketched. So this is still open to a debate. And I think also in the audience, there might be many experts who have also dedicated ideas on that. But I think that not only the mere presentation of the objects is interesting, but also some context, some results of one activity or one action. So in the sense that that person is crossing, but another one is also coming. So taking these complex scenarios together in order to give an immediate conception of what is going about outside. So not only just showing a picture, which is of course abstracted, it's not the real situation anymore. There is a certain abstraction, but this abstraction still might be too difficult to capture and grasp in such a short time. So it has to be communicated in a very sensible and thoughtful way. And that's up to research what has to be done still.
Yeah, thank you very much. So before we close this session, I would like to squeeze one more question from Raphael.
Hello. Yeah, very interesting presentation. I personally like the topic of internal HMI and how like information affects takeover control. It's exactly my topic of research. And there is been a lot of publications about how design of HMIs can effectively affect the way the drivers take over. But the thing that I would like to ask is that one thing that I've been perceiving in my study is that whenever there is a hazard in front, gaze, like vision is a mono channel, like you cannot look to two things at the same time. And generally hazards are known by literature to draw attention. Like for instance, so if you're requesting control in a very critical situation where supposedly the HMI would help because you're providing certain information, people don't necessarily look to the environment to like avoid the crash, but they look to the hazard because they are flustered by it. So I would like to know what's your, like, what do you think would be some possible countermeasures to this? And
yes, actually, I cannot answer that. But I think that's a very interesting aspect. So the question is, you're right. When is there a need for such a takeover situation? Is it in an ordinary situation, or is there per se always a hazard? Actually, we have been thinking that it might also be the case that it's an ordinary situation. So for instance, in Germany, we are discussing that autonomous driving is first going to come on the motorways and later in the more rural areas and then the city areas. So that's at least some expectations. And I could imagine that such a takeover situation could occur in a normal situation when you enter a city. And then you would not have such a hazardous situation as you described, but it would just to capture what is going on here. And I agree that if you have such a hazard, then there might be additional constraints that should be taken into account, and also to counteract what you say, that you're only looking at that and forgetting about the rest. Thank you very much for that hint.
Yeah, thank you. I'm looking forward for the publications about this. Like, it's very interesting topic.
Okay, so thank you very much, all of the presenters, and also thank you very much for the feedback in the question session. Now I would like to close this session and hand over the host to Hailong.